Hello everyone, welcome to today's webinar sponsored by deepset.ai, the company behind products like Haystack, an open source framework for building NLP applications, and Deepset Cloud, an end-to-end platform to build and deploy large language model LLM based applications, and InfoQ. My name is Srini Pinchikala. I am the lead editor at InfoQ for the AI, ML, and data engineering community. I will be the moderator for this webinar. Today we are going to hear from Mathis Lucka from the deepset.ai team. The presentation title is Beyond ChatGPT, Where to Start Improving Your Enterprise Search Application. Let me introduce our presenter first. Mathis currently serves as the head of product at deepset.ai organization. He and his team are building a leading development and deployment platform for LLMs in the enterprise. He has worked for the European Commission in the past. As a machine learning engineer, he has once won the Kaggle competition. As you all know, it's one of the most challenging and exciting communities for comparative ML. So for today's topic, we all know large language models or LLMs and generative AI technologies have been getting a lot of attention recently with the introduction of tools like Llama from Meta AI team, and of course GPT-4 from OpenAI organization. So these LLM models can also play an important role in enterprise search applications. So that will be the main focus for today's presentation. In this webinar, Mathis will share practical strategies on how to improve the document retrieval. Document retrieval is an important component of search system. So he's going to talk about how to improve the document retrieval for enterprise search. So you can take a full advantage of solutions like ChatGPT. So this will be a real world practical use case of how to use ChatGPT more than what we've been hearing how other people are using ChatGPT. So before we go to main presentation, I would like to go over a couple of housekeeping items. The main presentation will be about 30 to 35 minutes long. After that, we will have a 15 to 20 minute Q&A session where the presenter will respond to questions from the audience. I will be moderating the Q&A throughout the presentation. So if you have any questions during the talk, please post them in the questions tab in the GoToWebinar panel. So if you see the different tabs on the GoToWebinar control panel, there should be one for questions at the kind of bottom, second from bottom list of the tabs. Everyone's microphones will be muted by default except the speakers. The recording of this webinar will be available in the next couple of days to watch it offline. You'll be receiving an email with more details. So that's all for the housekeeping items. Mathis, I'm going to turn it over to you now, and I will turn off my video. Very much looking forward to the presentation.
Thanks a lot, Srini, for the introduction, and I'm very happy to be here to be presenting to all of you. I hope you get something out of this. And what I want to share with you today is basically everyone has been talking about GPT, ChatGPT, GPT-4, and it has been termed as kind of revolutionizing search as well. There was this battle kind of between Microsoft and Google even, where people said, oh, this is the end of Google search as we know it. And of course, many people turn to that because just like these very impressive natural language answers that you get from ChatGPT and the things it can do blew me away, definitely. But interestingly, actually, the first interaction that most people had with ChatGPT when actually searching for anything, because people were just relying on the knowledge of ChatGPT that it had encoded in its parameters, kind of. And for enterprise search applications, so a very practical use case, you probably want to look elsewhere if you really want to start improving your search, and if you really want to make it work with a model like ChatGPT, with a large language model. So let me start maybe with a few words on what we're working on here at DeepSet. We have an open source framework called Haystack. It's a Python framework for building NLP applications. It has everything you need to build applications for search, for named entity recognition, question answering, prompt pipelines with large language models. You can use agents as well. So we've been working really hard there to make something that caters to pragmatic builders who want to ship NLP products, who want to build NLP applications, and who want to do it in an easy and well abstracted way. And the other thing we're working on here at DeepSet is DeepSet Cloud, which I'm heading the product development of as well. And this is an end-to-end platform that's helping enterprises to build and deploy large language model applications. So whenever you need an NLP component like a search system with an LLM that should be integrated into your product that you want to use maybe for internal knowledge search in a knowledge base, or even externally facing, we have a product where basically lawyers can view case law and then find similar cases based on large language model predictions. And for companies looking to build these kind of things, there's a lot in the process of building that you need. You need the infrastructure, you need to collaborate as a product team working on that. Data scientists need to work with subject matter experts, with product managers, with software engineers, integrating all of it. And this is made really easy with DeepSet Cloud. So now I'd like to get right into the topic we're talking about today. I will first introduce retrieval augmentation as a concept. I'm sure many people have heard of it, but I want to cover the basics here. I also want to cover the basics of retrieval, different types of retrieval, vector-based retrieval, lexical retrieval. I will talk about metrics to see, okay, how do you actually know if your retrieval is any good? And then I want to share some strategies with you on improving your retrieval, specifically for the use case of retrieval augmentation used in enterprise search applications. And I'm going to share some results with you as well. So let's jump right into it. I want to make a pretty bold claim here, and that is, if you want to use large language models for enterprise search, the only way to do that should be retrieval augmentation. And of course, I'm going to tell you why. So basically, there are two very hard challenges for enterprise use cases when you want to use an LLM. The first challenge is you need to tailor the large language model to your use case. What does that mean? The model probably hasn't seen any of your data. Your data might be internal, it might be internal documentation, it might be contracts, it might be something that you have the copyright of and it's not published on the internet. And there's no chance for GPT or any other large language model to have seen that data during training. And then the second thing is that you probably work in a very specific domain. So your questions and the types of queries you run are very fine-grained, very specific. And large language models haven't been trained on this kind of data, probably. And the second problem that you definitely want to tackle, and here we see companies having very different priorities, definitely, but you always want to assure that the answers that a model generates for you have a certain quality. And a big part of that quality is the model should rely on your data and the information that you provide to the model and on that data only. And what language models often do is they make things up. It's what we call hallucinations. It's related to the way they were trained. They're trained to predict a likely sequence of tokens, of words, of sentences. And if the model has seen other information, it might predict something that is actually not true for your use case, that is not in your data. You might have technical documentation. We have a customer there providing basically a better search interface through technical manuals for pilots and technical service staff that service aircrafts. And if they search for something, the answer should better be based on the technical documentation that they've put into the system, because if it's just something that a language model made up, this will have very severe consequences, basically. But we also see it elsewhere where, I don't know, you have a end user facing product where it might actually harm your brand, maybe if the user sees a hallucination. So these are things that you really want to cover in your enterprise use case. I want to illustrate this a little bit, and I'm not going to use internal data here. So I'm just going to use the example of recent events. So here you can see a large language model pipeline underneath that mock interface. And if I'm asking, did SVB Silicon Valley Bank collapse? The answer is no, it didn't. It's a very successful financial services company. And this is an answer from ChatGPT. And basically, at the time of ChatGPT's training data cutoff, which was somewhere in September 2021, as it likes to say, this was true. Silicon Valley Bank didn't collapse, but now it actually did. And I wouldn't say it's a successful financial services company anymore. So this is really something that isn't true anymore, that the model kind of made up, or that at least is very different from the underlying data that we have now. And now, what's the basic strategy to prevent this? How do you teach the model about your data? What you do is, usually when you talk to a model, you would have a question. That question basically is your prompt. And then you give it to the large language model and you get an answer. So did SVB collapse? Yes. No, actually, in this case, it said no. So this is what you would usually do. And you're directly asking the model to produce something just from its internal representation of knowledge. You're not feeding any additional data. What you want to have is the prompt should actually be answer the question based on this data that I give you, based on these documents, grounded in this knowledge that we have and that I want to give to you, and you should just distill that knowledge, produce a better answer. So your prompt becomes answer the question based on this context. You insert any documents that you have that are relevant, and then you insert the question. And how do you get these documents, this context, into the prompt? Well, it's actually pretty simple. You add a retrieval component. How does that work? The retriever gets a question. It's connected to an external database, something like a vector database, for example. And then it can use different techniques to, based on your question, identify relevant documents. It gets these documents from the external database, and then you can feed it to the prompt. So that's the basic idea. This is what you want to do if you want to use ChatGPT for search, or any generative model for that matter. And basically, then the large language model kind of becomes a different interface to your data. It's still very useful, but in the end, it's very much dependent on that retrieval step before. So how does this retrieval work? Well, basically, to get it to work, what you want to do is you have data, you need to index your data into your document database. Indexing can mean a lot of things. You might want to do pre-processing, you might want to do some transformations, and then just write it into that database. Say it's Elasticsearch, say it's OpenSearch, say it's Quadrant, V8, Pinecone, any document storage really that also supports a search functionality. And then when you want to retrieve that data, you want to query that data, you have your query or question, go with it to the document database, and then you retrieve the relevant documents. And that's the basics. If you want to get a little more fancy, basically, you can use vector-based retrieval. Why would you want to use vector-based retrieval? Well, basically, it allows you to have semantic search where it doesn't just match keywords in your query and in the documents you have. Instead, it understands what you're asking for, what your question means, and then understands the context of the document and then can suggest something. And this is working really well for retrieval. So many people, as I'm sure you all know, are using this kind of retrieval. And so what changes when you compare, let's say, lexical retrieval, where you have no vectorizing and vector retrieval? Well, your indexing pipeline changes because what you will have is a transformer model in there. So a model that takes text and transforms it into a vector, but it's also the transformer as you know it. And then you have this vector representation of your text, and you're going to write that vector representation into your vector database. And then when you have a query, at query time, you also have that transformer model in there. It's still very fast because it only needs to vectorize that single query. It doesn't need to vectorize all of your documents. And then with that query vector, you go to the vector database and basically you use some kind of similarity operation to compare it to all the document vectors. Typically, that would be cosine similarity or dot product. And as a result, you then get a number or a ranked list of documents that are relevant to your query. And you get a similarity score that allows the ranking. So cosine somewhere between -1 and 1, for example. And then if it's 0.8, it's probably a very relevant document, something like that. Okay, so this is the basic retrieval step. And now, if you're working on your enterprise search application and you notice, okay, let's say I'm retrieving 3 documents. For each query, I'm retrieving 3 documents. And then I feed them to the large language model so that it generates a nice looking answer for me and identifies the really relevant bits within these documents. And as you can imagine, if these 3 documents don't contain the answer, the language model is going to have a hard time coming up with the correct answer, basically. If only some of them contain the correct answer, that might also be difficult. So what you really want to do is you want to evaluate, okay, how well is my retriever performing? How well does it support the task of the large language model identifying the right answer? And so you're going to ask yourself the question, okay, but how do I know if my retrieval is any good? Luckily, there's a very established field of research and practice in information retrieval, and there's a set of metrics that are very relevant to identify good performing, well-performing retrievers. But there's also trade-offs, and there's different strategies actually to evaluate. So one strategy to evaluate is evaluating on user feedback. You get a prototype up and running, and you invite subject matter experts to perform searches, and they should give feedback. And then you can measure the accuracy of your answers, the recall, the precision. I'm going to get into these later. And the pros of this approach are that this is exactly tailored to your data set. You're using your real data, and it reflects exactly how your users would use the search engine. So it's really the type of questions they would ask. The cons are, this is pretty costly to collect. You need people who actually manually perform the work and participate. It's difficult to have rapid prototyping in this case, because if you want to test 20, 30, 40, 50 different retrieval pipeline configurations, then people would have to give feedback for all of them. Otherwise, if you reuse that data, that might produce biased results or an unfair advantage, basically, for some of the pipelines. And then also the question is, have you selected the right people to test? And this is why we say you should always, as an other sciences, basically, use some sort of triangulation. So another method to evaluate your retrieval is to evaluate on academic benchmarks. These are data sets that were usually collected by academia, and they contain queries and relevant documents and irrelevant documents, and then you can benchmark your model on these queries. So you ask the query, put it through your retrieval pipeline, and then you know the ground truth, you know what the model retrieved, so you can measure how well it performs. And this allows you to iterate rapidly, so you can run one experiment after another. It's very fast. It's just the time that your model needs for inference, basically, that your pipeline needs to process these queries. You don't need to collect any data yourself, basically, because there are many data sets out there. But at the same time, what you lose is this is probably not reflecting your domain and your data specifically. And it might also not reflect how your actual users use the search engine. I don't know. Let's say MS Marco, a popular information retrieval data set, has a lot of keyword queries. So rather querying something by keywords instead of asking a natural language question. Your users might ask natural language questions. So that's different. And if you evaluate your system on a different benchmark, the actual performance might not match. So you really want to use both, basically. When you evaluate, you need to pay attention to your metrics, basically. And I'm going to talk about 3 basic metrics for information retrieval. I want to talk about recall first. Recall basically means when you issue a query, what percentage of the documents that should be retrieved actually are retrieved. So that means, let's say you have a query and you know there's 3 documents for that query that are relevant, and you retrieve 10 documents in total. And out of those 10 documents that you retrieved, only 2 of the relevant documents are there. So then your recall for that query would be something like 66.6%. And this metric is very good, but it also has some issues, or maybe not issues, but some attributes that you need to know. So one of them is it's not sensitive to the order of results. So having basically 2 out of 2 retrieved results in the top 3 is good, no matter if it's 1, 2, or 2, 3. Another thing is that if you increase the number of documents that you retrieve, this is what we call top K. So how many documents do you actually retrieve? Then your recall is also pretty much going to go up, because it's much easier to find a relevant document if you retrieve 10 documents instead of 3. For large language model applications and retrieval augmented generation, though, you might want to limit how many documents you retrieve, because 1, it's costly. So you're feeding more tokens to the large language model. So that's going to cost you more if you retrieve more documents. And the second issue is that we've seen that oftentimes LLMs basically get tripped up a little bit if there's too many documents that are irrelevant, and then it starts to hallucinate. So probably for your LLM application, you want to look at precision instead. Precision measures how high the ratio of relevant versus irrelevant results is. So let's say I have a top K of 3 and I retrieve 2 correct documents. In total, there's 3 correct documents, let's say. So my recall in this case would be 66.6%, and my precision as well. If I would increase the top K to 5, my recall would be 100%, but my precision went down to 50%. So this is a trade-off, as you can see. And you want to optimize for the right metrics. And I'd argue for large language model search, precision is a very good metric to optimize for. And then there's other metrics, just briefly. Mean reciprocal rank also takes into account the order of the results, for example. So there's many metrics that you can look at. I just wanted to give you 3 here. All right, and then what are some strategies to improve your retrieval now that you actually can measure the performance and you know how to interpret the metrics? How can you improve it? Well, I would say if you use vector search, select the right model. That's the first step. There's many pre-trained models. Try some of them. Try the ones that seem successful in benchmarks, but really try a few. You should also compare lexical and vector-based approaches. So lexical would be TF-IDF or BM25, vector-based we covered here. And then you want to optimize for the right metrics. And you might even try hybrid approaches. So where you have multiple retrievers and then you join the results kind of. And I want to show you how that optimization process could look in action. So I'm going to switch to our product here, actually. And I want to show you kind of 2 pipelines first. So this one is an indexing pipeline. You remember you need to convert your documents and you need to index them into your document database. I'm going to zoom in here a little bit. All right. So what you have here is you have a file that comes in, you have some conversions, you have a preprocessor, and then you have the embedding retriever. This vectorizes your files and it will, or the documents, and it will basically run, once you upload a file, it will run, vectorize it, and then it will write it to the document store. The query pipeline here looks very, I need to actually find it, looks very easy. So you have the query, it goes to the embedding retriever that vectorizes it, and then it returns the result. A more complex pipeline might look like this. So this one here is also a query pipeline. And what you can see here is you have a query. It goes to 2 retrievers. It goes to a keyword-based retriever and to an embedding retriever. So you're using both. In this case, BM25 and vector retrieval. Here, we even put a ranker behind the keyword-based retriever. This one basically is another transformer model that receives pre-selected documents from the keyword-based retriever and then re-ranks them so that it judges the relevance basically again. And then we put them into a join node, and that join node uses an algorithm called reciprocal rank fusion to join these 2 lists that you have. And based on their rank in these 2 lists, you will get a differently ranked list that combines the power of both of them, basically. And now I actually ran a bunch of experiments here. And experiments are this academic benchmark that I talked about. And the academic benchmark is, in our case, MS Marco. We have a data set, question, and relevant documents. And then we have a big pool of documents, and our task is to identify these relevant documents from that big pool of documents. And we're using this platform here to do that. And what you can see here is the precision recall trade-off, basically. So I have three experiments here, 3 pipelines that I tried out. All of them are vector search. And what you can see is that, okay, great, if I would optimize for recall, I should use this pipeline because the recall is 95%. And it's much higher than the other ones, of course, because we're retrieving more results. It's easier. For your large language model application, it might not yield the best results, because if you look at the precision, you're going to have a lot of irrelevant documents in this one here, and these might trip up your large language model. And here you have way less irrelevant documents. So this is one thing that you might want to look at with your experiments. Where do you have a recall precision balance that makes sense for your use case? But what you also can do is, so here we're now looking at a few more results. You can compare actually different models and approaches. So here, this one, we only use BM25, lexical retrieval. And basically what we get is recall pretty low and precision also pretty low. So this one doesn't perform that well for our use case. We have a hybrid approach here that performs much better. But let's maybe sort this by recall real quick. Okay, already sorted. So, but if you look at it and you want to identify actually the one that performs best, let's filter out, only filter for top K3, because this is the one that we want to use here. It has high precision, we want to have that. And then if you look here, you can actually see how they compare. So you can see that, okay, your vector search performs really well. And there's one hybrid re-ranking pipeline that has higher recall, but only slightly lower precision. It's a lot more costly to run this because you're issuing more queries. You have another model in there. So it's probably not the one that you want to select for your use case, because it will take more time, it will be more costly, and there's no performance benefit. You also don't want to probably use this one because, again, it has a model that might take more time, and there's no, it's weaker, basically. Hybrid retrieval, in this case, it also really doesn't work that well. If you go into this one, I ran a few more experiments, and basically what I found is that I found a vector search model that performs best. So I'm just going to use that for my use case and can go on and now test that with real users, for example. So I identified the best retrieval setup on my academic benchmark, actually 2 academic benchmarks that I used here, and now I can test it. And this is how you go on. And once that doesn't suffice anymore and you need even more performance, you will probably want to fine-tune your retriever, but this is a topic that we'll get into in another webinar. Yeah, so basically, to sum up, look at the right metrics, really rigorously benchmark your retrieval, and then you can have great LLM search experience. Yeah, I'm ready for QA.
Yeah, thanks, Mathis. Thank you so much for an excellent presentation. Everybody, please go ahead and post your questions in the questions tab in the control panel. I don't see any questions right now, but I'm sure you have questions that you would like to Mathis to kind of respond to. Mathis, in the meantime, I would like to start off with a couple of questions, right? So you mentioned about a couple of different document retrieval strategies. Now, can you add any additional comments on when to use each strategy?
Yes, of course. So for real world scenarios, there's basically a lot of things to consider. How big is my data set? How big is my corpus of documents? If it's really big, it might not be feasible to use vector search or too costly. For example, you might want to use a lexical approach, but it might also be that the benefits are great enough that you still want to use vector search. In general, if understanding the semantics of the query is important, vector search should be used probably. For very specific domains, sometimes the vector models are not optimized. BM25 has better performance. You can get around that if you actually fine-tune your vector search model, but that's a lot more work. So that's the trade-off as well. So really look at what makes sense. Look at how much latency can I have as well. What are the costs that I'm willing to pay, and then what is the performance I need, and then decide.
Okay, thank you. Yeah, I do see some questions from the attendees. So yeah, let me go through some of these questions. So Abhijit is asking, are those models stochastic? He's asking whether they are predictive or deterministic models.
So basically they are, they predict the vector basically. If you run them again and again, you will always get the same results on the same data, if that's the question. At least if you set seeds on how you load the model and everything.
Right, I think he has a continuation of the question. So he's asking like, do I have to train the LLM model with search and other logical abilities? So I'm not sure about the question. So I don't know if you have any comments on that.
So I think training the large language model for search specifically has a few issues. One of them is large language models are really costly to train. And for some of them, you don't even have access and cannot really train it. So you cannot take GPT-4 and train it on your use case, basically, not really. So that's already prevented. And then the other issue is you have to imagine you have millions of documents, but you can only really feed a few of them to the large language model. I know that Anthropic, for example, has a 100K token context size now, but the time it takes to actually run inference on these 100K tokens is so long that no user would wait for that in a search application. So you really don't want to train your large language model for search. You want to train your much smaller embedding model and embed all your data. And then you can have millions, even billions of documents. We have customers successfully running with more than 100 million documents, and they're using vector search and have sub 100 milliseconds response time.
Good, thank you. The next question is from Chris. He's asking, does the Haystack implement reciprocal rank fusion out of the box for Elasticsearch, or is that model out of the box, or how can we implement it?
Yes, Haystack implements reciprocal rank fusion out of the box. You can use it with any combination, really, with any document store. So not just with Elasticsearch, you can use it with all document stores that support lexical retrieval, for example, if you want to use lexical retrieval, but you can even combine two vector models. And the way you use it, there's a node called join node, and it has a join mode, and that is reciprocal rank fusion, and then you get it out of the box.
Cool, thank you. Yeah, I do see a lot of questions, so hopefully we can get through most of these. And if we don't have time to answer these, maybe we can reach out to the audience offline. So next question from Alexander. He's saying, thank you for the great presentation. And he has a question, how would you re-rank the results if you would use hybrid search approach, i.e. lexical and vector-based?
Sorry, could you repeat that again?
Yeah, he's asking like, how would you re-rank the results if you would use the hybrid search approach? If you are using hybrid search approach with the lexical and vector-based options, how would you re-rank the results? I think you showed it in the demo, right? So
yeah, so the way I did it in the demo was I retrieved 100 documents with BM25, and then I put these 100 documents into a re-ranking model, which is a transformer that sees query and document as a pair at the same time. So it needs to inference 100 samples basically live, which is still very fast because it's a very small model. And then from this re-ranked list, I take the top 5. I take the top 5 from the vector search model as well, and then I feed them into the join node using reciprocal rank fusion.
yep, and it's all part of the pipeline, right? So
yeah.
Okay. Next question, Amos is asking, do you have any suggestions for preparing and cleaning text that will be part of the documents to search for it? So this is basically make sure the input data is clean and of quality, right? So I don't know if you have any tools or techniques that you can recommend.
You mean for just in general the documents, or for training, like assembling a training set?
Yeah, this one looks like a general cleaning of the data before we send it to the training.
Okay, so yeah, I generally use Haystack for that. We have a preprocessor that can perform cleaning operations like white space, normalization, and these kinds of things. It can also chunk larger files. So a file might be a book, for example, and you really want to chunk it into smaller chunks because the vector model has a limited context size. So it can do that. And then we have different kinds of converters. I know that, for example, many customers have technical documentation which have a lot of tables. And then there's products from Azure, for example, that you can use in Haystack to actually extract these tables from PDF documents. So that would be something that I would do for tables. And yeah, that's in general what I do basically. Apply the right pre-processing for the right data. I don't do anything like stemming or I don't know, stop word removal, at least with vector search, because that's not needed basically in the case.
Right. Thank you. Okay, yeah, we do have a few more questions, so let's go through these. Suksi is asking, what is a reasonable range for recall and precision in real world use cases? Like what do you kind of see as the acceptable range?
Again, it really depends on your use case. How many results can you show, for example? Let's go away from that large language model use case. Let's say you just do document search. Do you show 10 results or do you show 1 result? What's the application? What do your users expect basically? Maybe in general, recall, I don't know, at a top K of 10 and a reasonably sized corpus of documents, I consider anything above 80% very good precision. Usually for pure search cases, I don't really care about that much. For LLM search, I want to have it somewhere between 20 and 40%, maybe something like that. But you have to figure it out for your use case.
Yeah, it all depends on the use case, right? So what's acceptable for one use case may not be acceptable for another use case. Okay. Couple of questions. I'm going to skip them. The next one is the question from Quinn. Question is, where was the time metric on how long it took to run the given AI LLM query? So I don't know if you mentioned this, Maths, but how long did that query that you showed in the demo took to complete?
So a single query on a pipeline takes, I don't know, I have to check. I can actually, wait, let me just briefly share that. I might be able to show to you even. Let me go to my pipeline. So this one, for example, is BM25 only. I have 120 milliseconds. Do I have queries for others? I think I have somewhere. So this one has re-ranking, for example. It has this model that needs to do 100 inferences. And here you can see 1.5 seconds. So that's much slower. For a vector model, I would probably be somewhere at 300 in this case, end-to-end, 300 milliseconds for a vector model. But you can optimize that. So these are just like quick experiments.
Right, yeah, that will be more of a trial and error for depending on the daily use case, right? So
yeah.
Okay. Let me see what other questions. I know there are a lot of other questions, but I'm trying to see which ones are more kind of interest to everybody. Yeah, this question from one of the attendees, like, what about fine-tuning the open source models FLAN T5? I think they're using that.
Yes, of course. You can fine-tune FLAN T5 even on that exact use case. So you can provide it with a prompt that already contains documents, and then have a ground truth answer, and then you can kind of see, you might even use reinforcement learning from human feedback, you might use traditional supervised fine-tuning. But again, I don't see that much value in it, because if you already have the right documents in your prompt, usually these models are very good in identifying the right answer and making it sound fluent and nice, at least the larger models. So again, I would really fine-tune the embedding model instead.
Thank you. Okay. A couple of questions that actually I was going to kind of ask you the same question. So I mean, the presentation was excellent. The demo was great. So how do our audience, who are interested in like kind of trying this out on their own, in their own time, what are the like? I know your last slide has some links. Like a GitHub is one of the links. So is that the one they can go to, or are there any specific tutorials or white papers they can refer to?
Yes, definitely. So if you want to learn more, we have a lot of webinar recordings, we have ebooks, NLP for developers is a favorite, NLP for product managers also very good. We have information on Deepset Cloud, our commercial product, at deepset.ai/deepsetcloud. And then, of course, if you want to play with Haystack, if you want to try it out, go to our GitHub, install it, try it out. We have great tutorials. Haystack.deepset.ai has you covered. You can try everything from that LLM search to agents to more traditional NLP tasks. Go and have fun, play, and build something useful. It's always great to see when the community does that.
I definitely know to get the real value out of this, it's good to try it out and kind of understand right one more time.
Yeah.
Okay. Yeah, I think we're down to maybe a couple more questions. Anybody else have any questions? Please post it in the QA. Even if you don't have time, we can they can be followed up offline. So let's see. Anthony is asking. Oh yeah, we are talking about that. Like where can you get the material to try it out? So Wendy is asking, how do you integrate this type of technology into your existing product that uses Elasticsearch and performs a query on a database?
Yes. So generally, I can tell you what our customers do that use DeepSet Cloud, and I can tell you what I would do with Haystack. So in DeepSet Cloud, basically what you saw, this platform where you have the experiments and these pipelines, you saw the queries briefly, latency. What people do is they deploy a pipeline, all the data is in there, they can sync the data to DeepSet Cloud, and then this pipeline exposes an API endpoint, or actually multiple endpoints, one for indexing the files, for uploading the files, and then they get indexed automatically, and then one query endpoint that you can integrate into your application. So a search request in your application, for example, goes to DeepSet Cloud, returns the results, and then you can display them or use them in any other way. So this is how they integrate, basically. And you can use everything that you do in Elasticsearch now. You can also do in DeepSet Cloud, because you have basically a storage backend of OpenSearch as well there. So you can use these things. And then in Haystack, what I would do is basically set up this pipeline. And we also have an Elasticsearch document store and an OpenSearch document store in Haystack. You can even bring your existing index, I think, and then set up this pipeline with this document store, indexing and querying pipeline as well, because you need to integrate your data, you need to create embeddings, and you need to query, and then host it somewhere, AWS, SageMaker, I don't know. Depending on what you use, you need a GPU, and then integrate it the same way, probably run it as a microservice and integrate it into your application.
Thank you. Yeah, actually, she had a follow-up question. So does this work with a SaaS model? I think if they have the Elasticsearch and the data and documents in a different cloud provider, how would you integrate with this model, right?
Yes, so DeepSet Cloud is a SaaS-based product. We do have functionality where customers can bring their own storage, so their own OpenSearch cluster and their own S3 file storage, and then we connect by a private link, so everything is safe and secure, remains in the VPC, and or the VPCs are coupled privately, basically, and then you can have your own cluster in there. So that's an option if you need that extra data security, data residency assurance.
Thank you. Okay, yeah, there are a couple more questions, but that's really good enough. Definitely, our attendees are very interested in this topic and have a lot of interesting questions. The next one is okay, it's a long question. So from Tycho, I'll read it, Mathis now. So with Haystack, how do you take recency, importance, and such of your retrieved documents into consideration for improving the quality of the generated answer? So I don't know if they're asking about the like a feedback loop kind of type of question, or do you have any comments on this?
I think we actually have very similar use cases very often. So recency, I don't know, let's say you have search on news articles. And of course, you mostly want to bring up more recent news articles. So that date back like a day or two, and not one news articles that date back 2 years. So how do you take that into account? There's a couple of different options. One of them in Haystack, you can provide custom mappings and custom queries to Elasticsearch and OpenSearch document stores. So you can boost these fields, and then you will have a ranking that takes recency into account. And another option is that you can actually create a custom node. That's very simple. There's also instructions on the Haystack documentation on how to do that. And you can basically, for example, get these results. They have the metadata, how recent is the result. And then based on that metadata, you can re-rank them to account for recency, maybe doing it in a weighted fashion. We actually implemented that for customer very recently.
Okay, thank you. Yeah, this is probably the last. Yeah, few other attendees, are complimenting, It's a great presentation. So this is the last question. We can wrap up after this. This is from Jean. What are the benefits of using the LLM to generate and rephrase the original user question, considering the retrieved context and or chart history? I think this is the kind of main focus of the presentation, right? How do you enrich the context of the question so ChatGPT or any of those other tools can provide the accurate answer, right? So yeah, if you have any additional comments, please go ahead.
Yeah, so I think basically the advantage is if you use a large language model, a generative model on top. One is, okay, let's say you have 10 documents that you retrieve, but the information you're looking for is actually spread out across these documents. So a user would have to go through all 10 results, and then they would know, kind of, okay, this is my answer. A large language model can aggregate these from these 10 documents. It can synthesize them. So one example is we have a demo where I can ask, I have earning calls transcripts, and I can ask, okay, could you please compare the revenue of Azure and Google Cloud, for example, and then it fetches the relevant passages of the Google or Alphabet earning call and the Microsoft earning call, and then can actually say, okay, Azure revenue was higher than Google Cloud, for example. And this is in different documents, but it already gives you the answer. So it's a very nice user experience. It makes you faster.
Yep, faster and get the, you don't have to do that extra manual work, right? And Anja, I missed this, Anja, I think I missed this question, but I don't know if it's really kind of adds any additional context to the discussion. But yeah, I'll ask that question anyway because I think this is the last one. If I found the relevant documents correctly, haven't I already solved my initial problem? I think the problem is not finding the documents, right? I think it's about answering the question by providing the documents as additional input, right? So, but go ahead, Mathis. Do you have any comments on that?
Yeah. I think basically think of the large language model as something that can provide additional value on top of these retrieved documents.
Right.
Not always, not for every use case, but if you want to aggregate, if you maybe retrieve a few more documents, if you only can show one document, but you can actually retrieve 5 and then only show the correct answer, because the language model is going to be better at, from these 5, get the right answer and formulate it in a way that the user likes. Also, think about customer support, for example. I ask a chatbot, I ask a question. I want to get that nice conversational answer and not the link to their documentation, maybe. So this is basically where the large language model can add value. But it depends on your use case. Normal document search might be fine for your use case.
Yep, makes sense. Cool. Thanks, Mathis. Yeah, that's all the questions I have. I don't see anything that we haven't answered yet. So again, thank you everybody for the most active discussion in the Q&A we had in a while. Yeah, thanks everybody for attending this webinar. This has been a very informative session, and I hope it was the same for you. You are the main reason why we host these webinar events, to share with the developer community the innovations happening in the software world, and LLMs and ChatGPT, and what Mathis discussed today is definitely one of the very practical use cases for the emerging trends in the space. So Mathis, do you have any final thoughts before we wrap up? We are almost at time.
This has been great. It's really enjoyable. I really value your questions. It's also great for me to learn where the community is at. And yeah, come visit us at Haystack on GitHub, contribute, use it. We have a Discord channel as well. Join it, try it out. If you have more questions, contact me, contact deepset. We are around basically.
Thank you, Mathis. Yeah, definitely refer to these links that Mathis is sharing on the slide, and check out the website, and definitely try it out and reach out to the team, if you have any questions. So thanks everybody for your time. We are almost at time, so thanks everybody for your time, and we will see you next time. Thank you. Bye.
Thank you. Bye.